what we've done, that they've asked me to pull up QRZ. So this is probably something that a lot of people use. Now, granted, there are a lot of different flavors of this, right? So sometimes you're actually looking at these and they're they go way down. They've got like sporadic E and all this kind of stuff for VHF and meteor scatter, and there's a lot of more stuff than this. Also know that Paul, I think it is, whose data this is, NONBH, he's in the process of updating them. There's some stuff here that is completely out of use. For example, and I'll just point to it right away, the 304 angstroms, see this 304A? That's 304 angstroms on Eve. So he has managed to update this one, good thing. A couple of them will say at SEM, set the SEM instrument on SOHO. I think it was on, no, was it on SOHO or was it on GOES? I forget where the SEM instrument was located, but if you see this saying SEM, SEM instead of Eve, it's not working. So what he's looking for in this particular wavelength here of light is the amount of extreme ultraviolet that is hitting our upper atmosphere and affecting mainly the F layer. So that's what they're looking at. And I think really what you need to look for is looking at big changes. So when you see this number go sky high in a short period of time, that's really when you're going to see the F layer get affected, and it may be getting better or getting worse. It's hard to say. But know that this 304 angstrom number only matters on the day side of Earth, not the night side. Okay, so I'm going to just mention that right away, just because that's one of the biggest things that has yet to be kind of updated. All right, so let's talk from the top down.
Sounds good.
SFI, that's solar flux, and I'll show you solar flux. I believe that's the solar flux index. 79, yeah, I think it's set. I thought it was a little bit higher than that right now, but we'll take a look. I'll show you Penticton in a short bit, which is actually a plot of the daily solar flux, so you can get a better idea. So here is the solar flux. So we're sitting in the marginal range. Anything above about 70 is the marginal range. Anything above about 90, 95 is getting into the good range. So we're creeping up, thank goodness, because solar minimum, we were in this like high 60s. So you can see we're continuing to creep up. Sunspot number, this is probably the smooth number, because right now I think we only have one sunspot on the Earth-facing disk, and this says 12. So this is a monthly smoothed number. That's why you got to be careful when you look at that. But it's showing that we are not spotless, at least. That's good. The A index, unless you're doing climatology, the A index is something you should ignore. Climatology doesn't really work for ham radio. I can't stand the fact that this number is used in ham radio. It really should be ignored, because all this is simply the KP index averaged over a day, right? First of all, the KP index, which you're going to see right here, K equals 1. That's the K index. And the P means planetary, so that's what PLNT or Y is. That K index, it's a global index, and it really works much better for mid latitudes than at high latitudes. If you're a high latitude amateur radio operator, the K index probably means very little to you. If you're mid latitudes, like in the United States, great. It works for you to some degree. It's a 3-hour averaged index, and basically what it indicates is how rattled the Earth's magnetic shield is. So if you see this K go up to, let's say, 4, okay, you could probably start having issues. Well, not start having issues. You've probably had issues for about 3 hours because this is upgraded or updated every 3 hours, and by the time you first notice it, you're already 3 hours into the disturbance. So K isn't necessarily my favorite index either. The best index to look at, if you're going to look at K indices, look at a local magnetometer around your area. You can have a local K index of 7, and the planetary index, which is averaged all around the mid-latitudes of the globe, will be 3, or 4. So it doesn't necessarily tell you exactly what the conditions are in your locale, right, in your local area. A lot of people, that's a big misnomer. A lot of people like to believe that space weather is just a global phenomenon, but it really isn't. There are global parts of it, right? Because you have the sun launching these massive things at you. That is a global kind of thing, because when it hits Earth, it's going to hit Earth. But the impacts of space weather can be local, just like weather. So it really depends upon the kind of phenomena that you're looking at as to where it hits and how long lasting those impacts are. And it really does matter what latitude and what local time you're at. So some of these numbers can be extremely misleading if you don't know where on the planet these numbers came from, right? And what they're talking about. PTN flux, that's proton flux. Okay, why you need to see the proton flux for, and I don't think this is even energetic proton flux. I think this is just basically helping you understand the D layer, both the proton flux and the electron flux. Where you need to watch these for differences, for impacts for you, would be if the numbers change rapidly. So if these numbers are only updated once a day, it's not going to help you all that much.
That flux will get you every time.
Yeah.
I'm just kidding. I'm just joking around.
What the flux are you talking about? Okay, so
boom.
So now the aurora. All right, this N1.99 is always that right now. Paul has yet to update this. He says this is going to go away. This was when he actually used to do this aurora number as a scale from 1 to 10, and so he had to scale it. Really, what he's reporting now, or is going, I think he is already starting to report it. He's reporting aurora in gigawatts. Right now it's at 1 because there's basically no aurora, but this is probably coming straight from the ovation model. For northern hemisphere, I would say anything above about 30, 35 gigawatts. So if this number goes from 1, it goes to 35. You might start getting auroral propagation around mid-latitudes. If you're up to 50, you'll definitely get auroral propagation, no problem. Anything above that, if you get to 100, step out of your ham shack and look at the sky. Because if this gets to about 100, there might be aurora above you, easily into the United States. So hopefully that gives you an idea of what that is. The latitude, of course, it'll tell you the latitude, how far down the aurora is coming. This is most likely a conservative estimate, because we're learning that a lot of the models that we have with aurora really underestimate how visible the aurora is on the planet. Thanks to social media, there are a lot more field reporters out there that are actually showing us how far the aurora reaches. And scientists have actually published papers on this now. Okay, so then BZ, that's how far southward the field is pointing. The bigger this gets, the more chance for a geomagnetic storm, the Earth responding, the Earth's magnetic shield to respond, and then of course K will go up. So really, if you want to look at this, if you see a negative number, because I'm sure it says negative, that's when you perk up your ears. If you see a -5 or high or below, right, -5, -6, on the way down, then really perk up your ears and take a look at this. This number here is the solar wind speed. If this is a rule of thumb, if this is below 5, so below -5, right, -5 or lower, and the solar wind speed is 400 or higher, you've got a geomagnetic storm if it lasts, okay? You'll start noticing propagation issues on the radio long before this rises, okay? Because this is real-time data, and it's getting it from our upstream monitors. Now, moving down here really fast, and I'll just do this quickly. This, to me, is something that you probably can't pay attention to. Why? Because where is it telling you this stuff is, right? I mean, it's saying day or night, what? The entire globe? The entire day side of Earth? The 80 to 40 meter band is fair? The entire night side of the globe? 80 meter to 40 meters is good? I doubt it. Go down to low latitudes and you'll find that the equatorial anomaly will totally make 80 and 40 not propagate at all, right? It really depends upon where you are, what latitude you're at. So these kind of conditions, if you've ever watched this stuff and it doesn't seem to concert with where you are, it's because your local effects are taking over, where this is just not, it's not robust enough to give you, space weather is not a global phenomenon when it comes to radio propagation. Right? It would be like saying, well, because it's raining in Southern California, it's obviously raining in Chicago. No, no one would look at that and say, oh yeah, of course it is. Of course it's raining. If it's raining in Milwaukee, it's going to be raining in Wisconsin. No, not true. No one questions that. So why would we think that this is okay? Right? radio propagation is fair in one locale doesn't mean it's going to be fair in another. So just be aware of that. Geomagnetic field, this is essentially the same kind of thing that we're talking about here. Where is how rattled is the Earth's magnetic shield? It's just basically telling you in words whether or not we're having a storm, and if we've got a busy or noisy geomagnetic field, then we're going to be, having issues with radio propagation, mainly on Earth's night side, and on 6 meters and 10 meters mainly. And then the noise level, again, where MUF, the maximum usable frequency, they're talking about Boulder. I think this says no repeater, so they don't have a repeater right now that they're pinging, maybe no ionosonde or something that they're trying to look at. I don't know if that's going to be updated or not. And then solar flare probability is just how active are the sunspots on the Earth-facing disk. Right now they say there's only a 9% chance, and that's going to change. That'll probably go up in the next couple of days because of the active regions that are going to be rotating into Earth view here shortly. So hopefully that helps.